Good morning, good evening, or good afternoon, depending on where you are. My name is Jakub, I am based in Poland. I know today you cannot see me, I have some problems with camera, but hey, it's Tanzu code, so the code should be visible, not myself, and the code will be visible. And just a friendly reminder, this is our weekly show, runs every Wednesday, 12 Pacific time. So mark your calendars. We talk about Tanzu, we talk about code, we talk about anything Spring related. So see you next week. But before that, today we are going to talk about testing your MVC layer with Spring, of course. All right, let's get it started. This is going to be like a short, maybe half an hour long demo with live coding. So hopefully the live coding demo gods are with us today, because otherwise I don't have any backup plan. Fingers crossed. So if you have followed some of the episodes on Tanzu Tuesday related to, for instance, event sourcing, or maybe basic modeling principles, or maybe testing the message-driven application, and so on and so forth, you are probably familiar with this example with credit card. But if you haven't, don't worry, because we are going to introduce our domain, our business problem, from scratch. So let's assume we are an enterprise and we grant credit cards. Before you get a credit card, you have to apply for a credit card. And the application rejects your application, or maybe accepts that application. In that case, you get the card. This is how it works. And this is our very simple architecture. So we have a credit card application controller, well, by which you can apply for a credit card. It's like an HTTP controller, and then this controller delegates to an application service which deals with the process of applying for a credit card. Probably we have some sort of a risk check there, and then you create an entity of credit card and you save it to the database via credit card repository. As simple as that. But this is just an architecture, this is just a diagram. Let's take a look at the actual code. So the code looks as follows. We have the credit card application controller, which you have just seen on the picture. And also we have seen that it delegates its work to apply for card service, which is a sort of an application service. The controller, it handles one HTTP method. In this case, it's just slash HTTP post, and we pass a request body. And inside of this request body, we pass the credit card application, so all of the data you need to apply for a credit card. In that case, we have something which is called PESEL. What is PESEL? What that is? So in Poland, which is the country, by the way, I am from, we have those unique identification numbers, and they are called PESELs. And each person gets its own PESEL, and the first two digits of your PESEL, they indicate the year in which you were born. As simple as that. So let's see how our application take advantage of the fact that we know when the applicant was born. So the credit card controller delegates to apply for card service to its method called apply. And if you were born before 70s, and we check that, well, you guessed that by taking a look at the identification number, very sophisticated risk check, you cannot get a card. I'm sorry, this is how our business works, and otherwise you can get a card with a default limit. And if you get that, we need to save it to the database so that you can use that in subsequent use cases when you want to withdraw money, for instance, or for instance when you want to repay money. On top of that, you pass some domain events to the external infrastructure or whatever is that. But today we are going to focus on this. So how to test the card application controller, how to test that whenever someone does HTTP post at slash nothing else, then with a specific body, they get 200 OK, or maybe if the card was not granted, 403 forbidden. So let's talk about different ways of testing that. By the way, we are going to see at least 3 ways of testing that. I'm not going to say that one of those ways is the best one. We are going to talk about different ways, and then according to your judgment, according to your problem at your organization, you have a choice to pick the one which fits the most the needs of your organization, the needs of your project, the constraints you have in your architecture, the state of your code base, and so on and so forth. All right? Let's get back to the presentation. So one of the ideas would be, well, this is like a Spring Boot application, right? So probably what we can do is we can run the application. We can start the application and listen for a connection, as it would do in production, right? And then we can also send an HTTP request and assert the response. So we start everything. We start the entire Spring context. We even start the server, and we make it to listen for a connection, just as it would do in production. And we'll just send an HTTP request, just like in production, and we can assert the response. In other ways, we are testing everything that's out there, everything. Let's try to implement that and then see what Spring Boot provides in order to do that. So I'm going to start a new class. I'm going to create a new class with our tests that's going to cover the entire architecture we currently have. Let's call it credit card application controller test. Well, so far so good. Probably later on we can think about a better name for that. Just notice one single fact, that when we name test classes like this, they're already coupled to our architecture, coupled to the classes we already have. So probably we should be naming test classes according to business scenarios, not according to technical components that are implementing those scenarios. But let's leave it like this. JUnit 5, or you know what? Let's stick to JUnit 4. We can do it in 4 or 5. Let's pretend it's like a legacy application where we have to choose JUnit 4 because of some reasons. Why not? All right. So I'm creating this class in the folder with Java. So here, what we can do. First and foremost, if I add Spring Boot test annotation, it tells Spring Boot to look for a main configuration class, the one probably which comes with the main class, so that one, annotated with Spring Boot application, and use that to start the Spring application context for the sake of the tests. All right? And also I can do something different. I can specify the web environment I would like to choose. Let's take a look at what I can do in here. Web environment defined port. Maybe I don't want defined port. I can choose random port. It's handy and useful to avoid conflicts in the test environments. So each of the tests can start its own port so that there are no conflicts. And now I can talk to my application, but hey, I have no idea what is the port I should talk to. Luckily enough, Spring provides it out of the box. How? I just need to specify local server port, int port, and now I'm ready to use the port that it was chosen thanks to this annotation in the subsequent test scenarios. So let's talk about test scenarios. All right, let's import this class. Let's enlarge a bit the fonts. Public, because it's JUnit 4, should grant the card. So let's test the scenario with 200 OK, HTTP 200 OK. So thanks to Spring Boot, we can automatically have provided something else. By something else, I mean a testing tool, which is called test REST template. And thanks to this tooling, I am now ready to write to implement the first scenario, because thanks to test REST template and the port I know, or my application knows, I can talk to my application via sending, well, HTTP messages. So let's start. When someone calls our application via test REST template, we can implement that. We are looking for post because the application handles one HTTP operation. In that case, it was post. We are posting for entity. So let's first pass the URL. So the URL is, I guess, as follows. The protocol, which is HTTP, it's localhost. We are doing that on my local machine. Port, well, that one. So I can just concatenate the string. And then, I guess, just this, slash. All right. What is the body? The request. So the request is new card application with my birthday. Let's say it was 89. All right. What next? What I want to get as the response. In that case, basically in the response body, I don't care what's there. I can pass void. All right. And this is our response. Let's just maybe choose better naming. Response sounds better. Then we can assert, for instance, that. Assert that response when it comes to the HTTP status, it's 200 okay. It's 200 successful. We want that to be true, right? Cool. It doesn't compile. Let me check why. Response, get status code, assert that. Probably different assert that method I need to import. I'm looking for assert J. That one. All right. So far so good. Let's see if that works. So that's an integration test, or maybe even end-to-end test. So it's going to take longer time to start, if it starts at all. We have non-pointer exception. Here, probably because I forgot about something very important, I need to specify to my testing framework that this should be running with Spring Runner. It works differently under JUnit 5 if you use JUnit 5, of course, but we have JUnit 4. Let's take a look right now if that works. That should do the job and that should correct our test. Hopefully, at least it should start. It is starting, and it's going to take some time to finish because, well, that's the entire environment we have, all of the beans, even the server, but the test is green. We can develop the second one, which will be, well, about card application rejection, I guess. So should reply with 403 when card not granted. Maybe let's call that one in a better way. Should reply with 200 when card granted. So in this case, we can just change the birthday to 70s or earlier. In that case, we want to see for something client error. That should be true. Let's rerun both tests and see if both of them are green. If they are green, we can proceed because that's the first way of testing your MVC layer. By the way, we are testing the entire application. We even start a web server on random port or on local host. So actually, the application behaves very similar to the way it would behave on production. All right, so far so good. Let's go back to slides. Maybe, just maybe, we can think about another useful approach. Another useful approach would be not to start the server at all. Maybe we don't want our test to be that heavy. Maybe we want to test everything from below. So, that case. By below, I mean the layer where Spring handles the incoming HTTP request and hands it off to your controller. That way, almost the full stack is used, and your code will be called in exactly the same way as if it were processing a real HTTP request, but without the cost of starting the actual HTTP server on your machine. That's another approach. Maybe you want that. That's a trade-off. You test less, but in an easier way, and the test has lower cost. So let's see how you can do that with Spring. So I guess we can try to modify this test and to tell Spring to use something like mock MVC, you need to pass an annotation, auto configure mock MVC. In that case, we don't need that. We want the entire context of Spring, but we don't want to start a web environment. We can auto configure the mock MVC, and we don't have the access to test-press template, but we have access to mock MVC. Let's call it mock MVC or MVC. And thanks to mock MVC, the one which is now injected, you can see on the screen, we can create fluent request, and we have fluent API to pass our expectations according to what is in the response. Enough of talking, let's see if that works. We can change it to expect, because that's going to be probably one-liner. All right, let's try. MVC, perform HTTP post. All right, let's import that. As you can see, we have the method called post in mock server HTTP request. I'm sorry, mock MVC request builders. I'm using that one, and I need to pass the URL. In this case, is just this, because we don't need the localhost and the port, because we are in the context of, well, just an application, not with the server. All right, the content type, or the content first, is, well, I need to pass the JSON right now. So that's going to be JSON with one piece of data. In this case, is the PESEL, the unique identification number, where the first 2 digits represent the year in which the applicant was born. So let's try to do that. We need to escape that. That's going to be that way. Let's say the person was born in 80s. All right. So far so good, hopefully. I'm not good with escaping JSON, so we'll see, by the way. So that's post, that's content. Then let's talk about content type. Oh, I need better formatting in here. Yeah. Oh, what's going on? All right, that's better. I guess we can format that in that way. Content type is going to be application/JSON, of course. I hope there is no typo. So that's what I want to do. That's what I want to perform. You know what? I don't like it. I want it that way. And now we can pass some expectations. I wanted the response, for instance, to be with a specific status, HTTP status. So let's import that. I want the status to be okay. Well, what's happening here? I know. This throws an exception, so let's just pass it to the method signature. I don't need this. Well, that was quick. Let's try to copy paste that to the second test. Of course, we are going to change the year in which the applicant was born to 60s, and let's run both tests. Well, I'm not using that, so let's delete it and see if the tests are green right now. Hopefully they will. So in this case, we are testing a little bit less without the server, so the test will be a little bit quicker. So again, according to your judgment, pick what fits the most the problem that you're going to solve. So one test is fine, the second one is not fine, probably because I didn't change the expectation. That's fine. So actually it's good, it's not green. I want forbidden here. Let's try it right now and see if that's green. All right, it is. So we have both tests which are green. Let's go back to slides. In this case, we are testing a little bit less, so that's a different approach. We don't start the server at all, but we test only the layer below, where Spring handles the incoming request, right? And hand it off to your controllers. So we still test a lot of things. Especially we also bootstrap the entire Spring context with add Spring Boot annotation, all right? But maybe, again, you just want to initialize the web layer, so just this, the web layer rather than the entire context. All right, so maybe I just want to test this, if my annotations are fine, if I'm handling responses with good statuses, with proper statuses, with proper headers, etc., etc. Maybe I just want to test this. I don't need entire context. I don't need apply for card service, the database, the repo in memory database, and so on and so forth. Just that, just this piece, just this slice. So Spring solves that issue with the idea of test slices. So we can have a slice for testing your data layer, or you can have a slice, for instance, for testing your MVC layer. So to do that, I don't need the context. I just want my application to run with a slice, MVC slice. Even I can pass the slice for the controller, which is on my interest. Maybe I want to test only that controller. All right. And still I can use mock MVC in the same manner, like here, the same way. But it creates one sort of problem, because if we take a look at the class, if we don't create the entire context of Spring, how would it know which dependency to pass in here? Well, let's check. You know what? I will run this test and see what happens. And if it fails, we are going to fix it somehow. It fails. Why? Failed to load application context. Error creating bin defined in file. No such bin definition, I guess, for apply for card service. Yes, because we don't start the entire context. So for the sake of this test, we need to pass a mock bin or stub of apply for card service. So thanks to this annotation, now with good old-fashioned Mockito, I can teach my dependency, apply for card service, which is a dependency from the point of view of credit card application controller, to behave in a teachable manner. Let's put it that way. So I can pass this Mockito when apply for card service. When someone wants to apply for a card with this identification number, then please, maybe 80s, then please grant her or him a card. So I'm going to pass an optional here of credit card with a default limit and this identification number of the credit card owner. All right, so this is given in our test. Let's simplify this, apply static import. All right, so far so good. Then we expect this to happen, right? So far so good, but maybe it's going to be good to pass the exact identification number to here, because otherwise I guess it wouldn't work. So now we are just testing the slice, and we replace the real dependency with a stubbed dependency. By dependency I mean the apply for card service. As you can see, the test is green and it was quicker. Fine, but we test less. Again, that's a trade-off. Depending on your problem, depending on what you want to test, what is the state of your code base, you have different options. All right. So one last thing to do is we need to check and correct this one. Given apply for card service, someone applies and the person was born in the 70s, maybe in that case we are not granting a card, which means the service returns an empty optional. All right, and now let's apply with this same identification number, and I guess this test should be green too, hopefully. Oh, nope, the same mistake as in the previous example, that should be forbidden. Let's rerun and see if that's still green. Or to be honest, to be fair, if that's green for the first time. All right, both of them are green, great. So far so good. Let's go back to slides and think about this scenario. So far we talked about that one, when we just examine the control in isolation with mock dependencies, but maybe there is a different application, not a real client, but a different application. I mean, not a physical client, but like a different computer, maybe that's a different service, whatever that is in this rectangle or square on the right side of this picture. Maybe you want to test if they communicate. And you want to test the communication without having to set up both of the applications on the same testing environment, because maybe you have more of them and you would have to set up like 10. In other words, you want to check whether they can communicate, whether the contract of the left application is met. If it's met, that means the right application on production can safely call it because it was tested. So in this case, in Spring Cloud, in Spring ecosystem, we have something which is called Spring Cloud Contract. It's basically for consumer-driven contract way of testing. In a nutshell, it works like this. You, as the producer of the API, so the one who's the owner of the credit card application API, and the one who exposes the HTTP post apply method, you also inside of your application can specify a contract like this. In Groovy, for instance, you pass the description of the contract and you say that whenever you call me under this, with this method, with those headers, with this body, so the person born in the 80s, 86 to be more precise, you get the response HTTP OK, 200. You can also use YAML, for instance. For 403 you get if you do something different. So you have different ways of specifying the contract. And if you build the application with Spring Cloud Contract and you have those contracts that you handwrite, the API, the framework will generate those kind of tests for you. So the thing we are testing we are taking a look at right now, those were auto-generated. I didn't have to specify them, I didn't have to implement them, I just had to declare the contract and the framework generated those tests. As you can see, they even are generated in this folder called generated test sources, which I guess makes sense because, well, these are generated test sources. And when you build your application, not only those are created, but also they are run. And if you actually meet your contract, that means you are not lying when it comes to your API. That means that whatever you say in the contract is actually met by your application. Then the build is successful, and also you, for instance, can deploy an artifact with stubs of your application that can be later on used by this different application, by this application on the right. Which means then the application on the right, on the testing environment, can safely use stubbed version of your API, but it's safe because it was verified when it was built by the left application. So in this way, you can actually test the entire communication from right to left without having to set up both applications at the same time on the same machine. All right, so this is another way of testing your API. Again, I'm not saying that some of those ways are always the best choices. I think we should be picking our tools according to the problem that we are trying to solve, and we need to understand the problem we are trying to solve. But in this short demo, we have taken a look at 3 or actually 4 different ways of testing the API, testing the MVC layer per se. All right, that's it. So remember, this is our weekly show. It runs every Wednesday, 12 Pacific time. So mark your calendars, and we will see you next Wednesday. So have a great day, or have a good night, or great afternoon, depending on where you are, and we'll see each other very soon. Bye bye.